All right, so this is a demo for Q with Multikueue, where we are going to showcase how we can uh, spread jobs across multiple Kubernetes clusters. And basically, we are talking about the batch jobs that you can run on your Kubernetes cluster. So if you want to have multiple clusters spread across different kind of environments, either on-prem or in cloud, and you want to schedule your batch jobs across those clusters, then you can leverage a queue with multi-queue. Um, and we are going to showcase how this can be done in this demo. So for the demo purpose, I am basically using three GKE clusters that are deployed inside a single GCP project. So here's the diagram that shows the infrastructure that we are going to use for this demo, uh, where our GKE clusters are deployed in a GCP project and inside a single VPC. So we are going to use one of the cluster as the manager cluster, and the other two clusters will be our worker clusters. Queue is already deployed on all three clusters with required resources, and multi-queue is also set up on all three clusters. So, and you can see in the diagram that we have the required resources already created in the cluster, which includes multi-queue related resources like multi-queue config, multi-queue cluster objects for each worker cluster, and the admission checks on the cluster queue. So we also have like the required typical objects for the queue, which includes resource flavor, cluster queues, local queues already created on all three clusters. So if you take a closer look at the cluster queue, basically we have defined a quota. On the manager cluster, we have a cluster queue with quota of CPU, 4 CPUs and 8 gigs of memory, which is basically the total sum of the quota that is available on the worker cluster. So each worker cluster has 2 CPUs and 4 gigs of memory. So that's why we have the manager has the total sum of the quota for each of the worker clusters, so that it can spread the jobs across the worker clusters. So manager will create the jobs on the worker clusters, and once the one of the worker cluster accepts the job, it will remove the job from the other worker cluster. And if the quota is not available on one worker cluster, it's going to send the job to the other, which we are going to see with this demo. So let's dive into the demo. So these are the three clusters that I'm using and that are deployed in my GCP project. And I'm going to use this job manifest, a sample job that we are going to create to uh, to see how the multi-queue behaves. So this job is just using a sleep and image to run the dummy job in the cluster, which is and this is going to run for 30 seconds. And we have assigned like 500 M CPU and 1 gig of memory to each of to this job. So once we are going to create multiple instances of this job, it's going to uh, occupy more resources, and we will see how the multi-queue will behave. All right. So and also we have this label defined on the job, which basically is pointing to the local queue, which is named as user-queue in our case. So this is the local queue that we have created. So each of these jobs that we are going to create is going to go into this local queue, and then it is going to uh, will be like uh, will consume the cluster queue that is also created on the clusters. So let's dive into the demo. Let me create the job and see how manager cluster will. So you can see the job is created on this is the manager cluster, which is, and I'm basically observing the jobs and pods object under the test namespace. So everything we are doing is under the test namespace. This is cluster one, which is our manager cluster. This is cluster two, which is our first worker cluster, and this is cluster three, which is our second worker cluster. So when we created the job on the manager cluster, it basically dispatched the job onto the worker, and cluster 2 accepted the job. So the job is running, and now the job is completed. So we can see it's showing up as complete on the manager as well. All right, so now I'm going to create more jobs to see how the multi-queue cluster will behave, I've created another job. It again goes to the first worker cluster, which has the capacity. So I'm going to create another job, and this goes to the second worker cluster. Now I'm creating more jobs to see. So the jobs are going to the first worker cluster, and now the the first worker cluster doesn't have the capacity, so the jobs are going to the second worker cluster. So this is how basically multi-queue handles the jobs across multiple clusters, and it can basically handle the workload depending on the quota that is available on your worker clusters.